Okay, last section of chapter 1. We've got experiments is what we're looking at here. So let's get started on our last section in chapter 1. Okay, treatment group, control group. We mentioned this briefly in the very first lesson. So the treatment group is a group that is receiving whatever you are being tested, and the control group is not receiving that type of treatment. We talked about this with the stents. Um, and the goal of an experiment is to see if the treatment is the explanatory variable. So if we change that one thing, is that what's going to help or hinder the treatment group? Okay, and so that's what we want to judge for. And so what we try to do is we try to create a controlled experiment where everything is the same except for that one little thing. The problem is that it's very hard for us to contain everything kind of in a bubble to be able to test that one thing. So we'd have to do multiple of these. So there are a few things when we're doing clinical studies, which is what we're kind of looking at here. First off is a placebo. So what a placebo is, which you've probably heard used now and again, is basically a fake treatment. It's often used with the control group to see if it changes anything. So what a placebo does is the idea is that your mind is making you have an effect even though it's not really having an effect on you. So you've also heard there also might have heard people say it's a sugar pill. So I'm going to give you this. It's a sugar pill or it's a vitamin. But it's this magical thing that helps you feel better. That's a placebo. So the placebo effect is actually an experimental. It's an improvement on somebody that was given a placebo, was not actually given the special treatment. So that's why we have our experiment and our control, and you can throw in a placebo. You can give all your controlled people a fake treatment to see if it is the medicine or if it's more mind and, I'm feeling better because of my mind. Okay. So that's a placebo. Next up is our blinding. So you have a blind study and a double blind study, or it might not be blind at all. And the blinding is basically telling you how open and up front are you at the beginning of the study. So if it's an open study, you basically, whoever is in your groups, which they've said they wanted to be a part of your groups, you basically tell them you're in the control group or you're in the treatment group. Here's the medicine. That's an open one. It's sight, you can see it all the way through. A blind study basically would be, okay, you guys are, here's your groups. Okay, this is group A, this is group B, but here I'm giving all of you a pill. But B doesn't know that they're actually the treatment group and A is the control group. They don't know. So if the people don't know that are participating in it, that are in each group, that's a blind study. A double blind study is where you go the extra step and the people that are working with each groups also don't know. So this is more for like if they're sending out medicine to many different doctors across the country. Some of the doctors, they won't tell because they don't want the doctors to tell the patients, hey, I'm giving you medicine or anything like that. So a double blind study would be those that are communicating with the patients. They are the ones that also do not know which is the controlled or the treatment group. But the person that's in charge, the people that aren't dealing with the patients, they still know which is which. Okay, so that's how you can still do it. But the people that are directly involved communicating with each groups, they are blind of it as well. That's a double blind study. So no one that's actually participating knows. The only ones that know are those that are kind of, behind the curtain. Okay, so 3 principles for an experimental design. This is what we want whenever we're doing these clinical studies. So number 1, we want to have direct control. We want all the groups to have the exact same except for what's being treated. The problem is that there's outside forces you can't deal with. But we want to try to keep it all the same for everyone. Try to keep everything similar except for that one treatment because that's what we want to see if that's what's going to change. Next is randomization. You want everybody participating to be randomly assigned. So you don't want just to go, okay, I'm putting all these people on one side and these people on another because they showed up first. You don't want it that way. Or these people are older, so I'm putting them in a group. No, you want it random because you don't want to put any uncontrolled variables in together as a group. So if you do like the older and younger, older people might react to something different than younger people. Men might react to something different than female. Okay. And replication. So basically, if you do it once, you should be able to do it over and over and over and over again. The problem with a lot of clinical studies that are like, oh, big news, yada, 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 they've done it once and it's happened that way once. They can't replicate it. So that's the one problem. That's number 3 is the big one that a lot of people can't do, is that they can't replicate as a result of something crazy. Oh, if you eat chocolate, you're going to lose weight because of this, because we did one clinical study that did it, but no other ones did it. But one did. So you've got to make sure you can replicate it. Okay, blocking. So blocking, we mentioned previously, there was one question where there was a blocking was one of the options. And basically what blocking is, it's stratifying, but you're using it with an experiment instead of a sample. And so what you would do is, like, you can go male, female, and then you go, okay, you guys are in blocks, and then you pick randomly from each one and put them in their groups. And so blocking basically puts everybody in a group based on a single characteristic and then pulling them from there. You're putting them in strata. That's what you're doing, and then you're randomly assigning them into groups. But you're actually doing it in an experiment. That's why it's blocking instead of a sample. So a sample, you use stratified. Experiment, you're using blocking. Okay, so that's kind of the difference. Okay, so let's say we have this example where we have a experimental gel that we say will make people run faster. The treatment group gets the gel, the control group doesn't. Okay, so do we just give some people the gel and not others? Should we separate it with male and female? Should we do pro runners and amateur runners? And this is where this blocking stuff comes into play, because you can go and you can go, okay, if I just give it to them randomly, that's what the result is. It randomly will help people. But you could also break down, okay, I'm going to look at, if some men and some women get it controlled, and then you can look at and go, oh, it works better for men than it does for women, or it works better for women than it does for men. You could also do it with pro runners and amateur runners. So if it's an amateur runner, it's somebody that just runs for exercise compared to a pro runner who runs races. And you can go, okay, whose is better? Oh, it helps amateur runners get closer up to that pros, but it doesn't help pros. Okay, so that's where you can do blocking, is that you can put them in groups like that and you can see. Okay, so this is something that you'll probably want to write down. You can pause the video and see it. So basically, looking at this, you've got your random sample, random assignment, causation, generalization. This is your ideal. So if you have a random assignment with random sampling, basically in a study, an experiment, that's your ideal experiment, is if you can random both. If you can't randomize one of the samples, then it's going to be more, it's where most experiments are. On the other side, with this one, you've got more of your observational. So no random assignment, but you have some random sampling, that's an observation. If you have no random sampling, that's a bad observational study. So basically you're cherry picking, is this one down here, is that you're cherry picking your data. Alright, so there's your homework on the last part, and kind of a big section, and that's the end of section 5. Okay.